I will send Gina the link in case she's got which tab. Ah, here we go. Boof.
Cool. All right.
Oh, cool. Hold on, I'll answer you. I'm on it.
Oh, okay.
Yeah.
Thank you. Okay, I can do that. Good afternoon. This is a room for pass-aware networking research group. Please make sure you're in the right room. I'm quite sure you are. So, I'm Jen. Here is Brian in person.
Once a year or so.
Yeah, once a year. So, let's get started. This is IETF Node 12, which is slightly different from IETF Node 12. So please take your time to take a look at this, read it. But basically, yeah, what it says that you, by being in this room, you basically agree to follow IETF policies and processes, and you need to let us know if you are aware of any intellectual property, and you know that everything is recorded, so whatever you say is part of IETF participation, and you are expected to behave. Be nice to each other and to other participants and express your technical disagreement in nice and polite way. Housekeeping. So if you want to join the queue, even if you are in the room, please still join Meetup queue by either scanning QR code on the microphone, or you can use on-site client from the agenda. And please raise your hand and join the queue, because it would make it much easier for us to manage the queue. And please put your phone in the silent mode if possible. If you are participating remotely, please turn your audio video off unless you're actively presenting or speaking in the queue. If you're presenting remotely, actually don't know, I don't think we have remote presentations today. But anyway, if you're presenting remotely, you can share your slides, or you can ask me to control your slides. We have minutes taker, great agenda.
Do you know you found Hedgedoc? Yeah. Cool.
Yeah, and please, especially if you participate in, saying something in the mic, please check meeting minutes and add things there if you think that what you said wasn't captured. So here is our agenda. We have 4 presentations, and we have even some time for open mic. Any last minute agenda bashing? Everyone is happy and satisfied? Great. So there is no slide about working group documents, for we have not done any for a while. Yes. So I guess we can start with the first presenter, unless you, Brian, do you want to add anything?
No, I think we can call Luigi up.
Okay, Luigi, you're up. Okay. Oh God, how do I do that? Wait.
So I'm Luigi Yannon, and not you Yannon, unless there is a second Luigi in the room, which is pretty rare here in the IETF.
I'm granting you slides, correct?
Yeah.
Got it? No?
It went directly on.
Yeah, but you're on the. You got to bring up. You got to share.
Control on
You got
your
to bring the other
slides,
slides
maybe.
up.
Yes. Okay.
Yeah.
Yeah, which is not.
Control over all of the slides.
Hold on.
Whichever we
Okay,
happen to be
I will
showing.
share the.
God. Okay.
Wait, wait. I
Okay.
asked again.
Now, grant preloaded slides.
Okay, and this.
Wait, it's pulling it back.
And this.
1, 2. Yes,
And,
much
and
better.
here we go.
Thank you.
Okay, back. So, I'm here to describe a little bit above we had during 120, so, and which is kind of ongoing in the sense that we are not meeting it during this IETF. We plan to meet again in Bangkok. Okay, the name is Network Attestation for Secure Routing. As you will see, is how to say, relevant, yes, for this research group. A few pointers and historical pointers. We have 3 internet draft, and there was a first side meeting in 118, then a more official side meeting in 119, and the official BOF in 120, as I said. And we received a lot of feedback, including coming here to talk with you. And that's why we are still working on, let's say, on all the feedback we received. So what is all about? What is the problem we try to solve? So the problem is that we don't necessarily control the path where our traffic goes through, okay? We don't have a direct vision on whether or not it goes through unsecure or kind of untrusted devices, okay, that could copy the traffic and crypto-analyze this later, can do some forgery, et cetera, et cetera. So the point is we want to achieve a dependable hop-by-hop forwarding on top of devices that we trust, okay? And so that we minimize the risk. And there are a few use cases that can be, that are relevant on this kind of problem, okay? And here we go. Now you can say, yeah, you can use a VPN, use TLS, IPsec. True, but there are still some risks, okay? You can still want to copy the packets and detect them later. You may want not to go through devices that have maybe an old OS, or they are using a version of the crypto support that is known for being weak or having problems in the implementation, right? Or maybe you don't want data exposure, okay? At VPNs, you have something in the middle that may be a point of weakness, let's say, okay? So what we want is to create auditing tools so that we are able to audit the path and have some proof of transit, which should be here. So this is something that is lacking, okay? The fact that from a certain perspective, I can audit the path that someone gives to me, okay? And make sure that is conform to some properties that I desire, okay? But this is only part of the gap, let's say, because assuming I choose a path, I audit, I know this is the path I want because satisfies my requirements. How to make sure actually the traffic goes through this path? Because I send it, automatically goes on the other side, but did it go exactly through the path I chose? So we want a second part, so to have a way to have a proof of the transit, okay, that exactly my traffic went through the right path. I mean, here you have an excerpt of the charter of this research group, and I mean, the last sentence put in bold is very relevant here. So if the endpoints cannot control the path, at least they can determine the properties of the path by choosing a more path available to them. So this is exactly what we want to do. I have a set of paths available, okay? I audit them, and then I select the one that is more suitable to me from a certain trustworthiness that I need, okay, your properties, okay? And then I send my traffic, and possibly I audit the fact that my traffic goes through the path that I selected. So, and I think that's all I have to say. except asking for feedback if it goes to the last slide. So, any question or comment? Please come talk to me. Would be good if you want to participate. We have obviously the mailing list. Come and talk. Okay.
So there was a BOF that was this week, correct? That's already happened. No.
So there was a first non-working group forming BOF back in Vancouver.
Okay.
So
Yeah.
this summer.
Yep.
As I said, we had a lot of feedback, and we are still working on that.
Okay.
So we decided not to hurry up.
Okay. Okay.
And we meet this week. The next one will be in Bangkok.
Bangkok. Excellent. So.
And one of the feedback was, oh, go to PANRG
Yes.
and talk to them.
Yes.
Because we are related. We are cousins.
Yep. Absolutely.
So,
Queues are open if anyone has any questions. Otherwise, please follow up with Luigi on the list or directly. Oh, wait. Don't fall over. We got John.
John Scudder. Okay, sorry.
Hey, John Scudder. Sorry if this repeats a question from the BOF that I wasn't able to be at, but so you mentioned on your slides, proof of transit and proof of the properties of the things that you transit. The thing I didn't see on the slides was proof of non-transit, which is to say, I think you get my point. So why don't you just speak to it?
Yeah, thank you very much for the excellent question. Now, the point is that is a very more difficult problem to solve. Okay, we see something. We see that the problem. Say we have an idea how to prove that the packets go through some points. Okay, but proving that these packets do not go through other points, it's much bigger problem, and we don't believe it's actually solvable in the IETF itself. It's at least not now.
I actually am inclined to agree, but I'm not completely clear how you, the motivating use cases you presented. I'm not sure how those are all satisfied if you can't prove that there wasn't, some other device in the middle that had the opportunity to inspect the traffic.
That's true, but what I said is that just that the traffic goes through a certain path or certain nodes. There is a limitation in what you can do. It depends on the visibility and granularity. You are completely right. Now, I was about to add that this part of the proof of non-transit was not sufficiently clarified in everything in the documents and in the BOF itself. So the question is absolutely relevant, and we need totally to clarify what is actually the scope and what can we prove and what we cannot prove. Okay, so that I mean, adopters have to make a choice based on this pro and cons and balance the risks.
Okay, thanks very much.
Thank you. Peter.
Hi, Peter Liu here from Huawei. I just want to add a little bit about the proof of non-transit thing, because it's more like a visibility issue, like you're visible with the L3 devices or L2 devices. So obviously, like layer 2 switches and that kind of device is much more harder to be discovered or be proved that nothing's in between. But when we are dealing with the layer 3 devices, we kind of taking an input that some very important information like the ingress and egress interfaces of a packet, such that if there's like a deviation or deroutes when we are designing a very practical way of proof of transit when using iterated hash functions, then if you have like a like a repetitive processing of packets or the wrong order of packets, anything that happens wrong in the layer 3, then you have very incorrect results of the hashing canonical verification. But anything that's in the layer 2, I think this is more consideration, but I think that's not completely not doable.
Hi.
Let's have more questions. Max.
Hi. Max Funke. I don't know if you talked to physical layer security people at all yet. This would not be part of the IETF, but I think this would be very interesting for them because they can basically give you very, very, very good security characteristics for single links. But the issue they have right now is that they have no way to integrate this end to end and so on, right? So they actually do a lot of like double encryption. They always still use TLS, but still somehow do stuff on the physical layer that encrypts it again. But I think if you were talking to those people, they would be very interested.
Good point. Thank you.
Rüdiger Volk, I find myself sometimes in the wrong places, like right now here and last time at that BOF.
This is PANRG. You are
No, I know.
just joking. Just joking.
I was quite unhappy what I was seeing, but Luigi, as I'm seeing your slides right now, my question would be, is it essential to know the path? Or would it be sufficient to have proof that only elements that are acceptable and certified in some way have been passed?
So basically, so you are asking whether or not the problem is irrelevant.
No. Well, okay, if it is a realistic problem in the economies is a very different thing. No, I'm kind of looking at your slide and I'm seeing 2 bullets at the end. And it kind of, I'm looking at it and I'm thinking, do I need the first bullet as a prerequisite for satisfying the second? And it appears to me that that is not really necessary.
I think I understood the point. So first of all, if I have a path, I'm able to audit and is the path that I want trustable. Do I need the second point? Maybe not. It's not. The point is not that you need both together as a mandatory. I mean, but in some cases, you want also the second bullet. And as an additional maybe comment, one of the things that was completely unclear the last time, this will not be a general service for the when I go on a Google page or through the internet. This is not at all that case. So it's something that is more of a specific service that some customers may need.
Kind of, we are not on the same tracks, it seems. Okay. Proving that a packet goes over a predefined path kind of does not include the assertion that I know something about all the elements passed. That's in the second bullet. And kind of that can be satisfied potentially without the first. It may be
so
hard.
You are saying
it is a different technical problem. And I'm stopping my rants with the remark that I would like the trademark routing security reserved for people who are actually working on routing protocols, which is a different
different point. I can agree on that.
Rüdiger, I'll give you that trademark if people who are working on transport protocols can take the trademark transport. We'll take that one offline.
Thank you very much, Rudiger. This is another point that was raised during the BOF, whether this is routing or forwarding. And some impression was that we're going to do trusted routing or build a new routing system or whatever. This is not absolutely the case. I can agree the name is a bit misleading. We'll keep it or not, I don't know. This is up to the group to decide. I mean, but point taken, absolutely.
Okay.
Okay, thank you very much. Okay, the next presenter, Nicola.
Give them the thing.
Yes, share.
Yeah. Boom. Yep.
Boom. Boom.
Yes. Did we do the thing?
Yes, I think I did.
Okay. Do you have the control?
Yeah, I have control, but
You're gonna switch. Yeah. No, you got to do something to get the slides up.
I mean, these are the slides that came up, so stop. I can ask again.
Yeah.
Yeah.
Right.
It
you have-
doesn't
we have
let
to
me
make- Yeah, it doesn't let you change the thing, but it lets you change.
Ah, now
yeah,
I can
now
pick
you
it. Now I
Yep,
can
yep,
pick
yep.
it. And yeah, I think that's it. All right. Thank you, Jen, and thank you, Brian. I wanted to give you a short update regarding what happened to the Scion draft. So if you're here, I think you probably already heard about Scion. It is a path-aware architecture focused on, I would say, that path security and path authorization. So we have some productive deployment in the finance industry in Switzerland. There is also a deployment on a global research network that is based on Scion, and this will be later today. I think actually the person is remote though. And so we have been discussing this topic here in this research group for a while. Our initial goal was, first of all, to document what exists today in terms of current deployments. And after various discussions, we decided, we also got advice that the best path forward for this was the ICE, to basically take a snapshot of what exists today, what is deployed. And of course, this is just a starting point, so this can be then taken as a basis for future work. So just to recap the drafts that I'm talking about right now are three, and they describe the three key components of Scion. So these are the PKI, it basically has a trust model. It provides certificates for the control plane. The control plane is doing this route discovery process, and then it distributes the paths to endpoint, and the data plane that is doing forwarding. So these are the key specification drafts. You might have seen some earlier drafts, like an overview and a component analysis. These are now expired, so we haven't maintained them, so please look at the core specifications rather than the overview. While going through this process, we also got feedback, some of which we can't really address in the specification, also because this is already deployed, so we want to take a snapshot of what we exist, but there's definitely things that can be improved, and because of that, we also created two research question draft and a deployment question drafts, and later my colleague Kevin will talk about it. So what happened through this review process? Well, this happens a bit behind the scenes, but I thought it might be of interest to this research group to share some of the feedback. We found it very helpful. So I already gave a bit of an overview at the last PANRG about some previous updates. If you want to know more, maybe you can go and look at my past presentation. The key things that we changed back then was that we introduced a default MAC algorithm for all implementation to ensure interoperability. There were some deployment considerations, like how do you run, what do you need to configure a Scion autonomous system. We specified better the control plane APIs and so on. And of course, we had a new section on scalability and security considerations. I think this came even earlier. So what happened since last IETF and in the last review cycle? We still got quite some interesting feedback, especially regarding the data plane. This was also the less mature of the 3 drafts. So there was quite some work, both on the editorial part, on better clarifying the text. We also added an introduction, trying to clarify the goal both of Scion and of this draft specifically, which is, as I mentioned, to document the existing implementation as in the deployment. And so if you want to know more and also follow what changed, the drafts also have a changelog at the end. So that should help you to figure out what has happened. So what were the key questions that we got and how we addressed them? One of it was, how do you handle failures? So Scion is a path-aware network. If a path goes down, then how does the endpoint know about it and switches to a new path? And so Scion has a control message protocol that is called SCMP, Scion Control Message Protocol, kind of similar to ICMP. We initially didn't have it in the spec, and following the questions from the reviewers, we had to add it. We actually added it to the data plane, but this is a control plane protocol, so we have to move it. And then there's a couple of other messages. So this is one thing. Then another one was about MTU. So if you have seen the header, you know it is quite a header. So the MTU is a bit smaller, and of course it can change depending on the path, because for the longer the path, you know, the lower the MTU, because you need more space for the header. And so we clarified how this works in the current network. Right now, operators just configure their intra-AS MTU. Then this data is distributed by the control plane to endpoints, so that whenever they do path lookup, then the endpoints can already calculate what is the path MTU. This seems to work quite well in the current deployment, so there is no active discovery of this MTU. We also clarified that there is no fragmentation, so this has to be handled by upper layer protocols. We clarify what are the requirements in terms of MTU for the layer below Scion, and I'll get to that I think in the next slide. There were some other questions that we got quite a lot, so we hope to make the text a bit clearer. Many people asked, where is Scion in the stack? And while in principle it might be run directly on layer 3, in practice in the current deployment, it is run on top of UDP/IP for backwards compatibility with the intra-AS network. So we added a figure about that. We got asked whether there is checksums on payloads, and this is the answer is no. We also added some pointers about how you can test if you have a Scion implementation, and so we added a pointer to this Scion Lab testbed. We added more deployment considerations, especially in terms of monitoring. So what do you need to keep an eye on if you want to make sure that service continues to maintain availability. There were also a few, there was also some feedback that was very interesting because it was more architectural, but that we couldn't really address in the drafts because, we are trying to document something already existing. So one thing that we have in the draft is a cross-layer checksum. So right now, UDP on top of Scion has a checksums based on the Scion header. And yeah, this was a bit controversial. So maybe this is something that we need to reevaluate at some point. There is the whole topic of interoperability where there are gateways, several deployment models, but this part is still a bit more experimental. So this is not really part of the draft. There was some other feedback about some other topics like multi-ISD membership and also some policies when it comes to running, basically routing into an AS. So this is something that, of course, we can address at a later time if there is some work that then will be based on these drafts. And so we try to keep this in consideration for the research and deployment questions draft. And I think for that, my colleague Kevin, who is one of the authors, will give a quick overview. All right. I can change the slides for you.
Change the one slide, I think. All right, so whilst we've been focusing on documenting the core Scion components that are specified in these three drafts that have been presented by Nico, the Scion community has also been working on a number of other elements that are essential to running, well, that are not essential to running Scion, but which could be supported in future. So there's also some ongoing research into some of the core elements of Scion that can be documented. So rather than confusing the core specifications, which are the sort of the base set of things that need to be done to implement Scion, we pulled together another draft for the research questions, which is really at the stage of collecting ideas, documenting the existing work, and addressing potential gaps. And I think Nico alluded to what some of those things were. So we have, perhaps the sort of main question is around how intra and inter-ISD beaconing will scale. And really sort of questions, how much do we expect the number of ISDs and ASs to grow within the Scion ecosystem? I think Nick already mentioned that ISDs belonging to more than one, ASs belonging to more than one ISD. And then there's also sort of questions of how we expect ISDs to be used as we go forward. A couple of other issues, how beacon selection policies work, and also how beacon propagation can be optimized. I think DR key, was already shown. So this was previously an internet draft that was around, I think, about a year or two, 3 years, maybe longer, 4 years ago even. So this expired, but this work is actually quite useful. So this DR key is really allowing any host to obtain a symmetric key from a Scion PKI, really to enable source address validation. And this can be used for the basis of proof of transit. So this may yet see another reappearance. SCMP, again, mentioned by Nico, that has been specified. Well, it's currently in the data plane draft, but that will move to the control plane draft. But that's actually unauthenticated at the moment. So there is potential for potential forged messages in that scenario. So we're also looking at authentication for SCMP. You have something called Fabrid, well, Epic and Fabrid. So Fabrid is the successor, so to speak, of Epic. And this is allowing inter-domain traffic to cross an AS without the need to disclose the topology within the, or the AS doesn't need to disclose its internal topology. Hummingbird, this is a quality of service potential addition. We haven't looked too much of that at the moment. This is work that's been ongoing at ETH in Zurich. One thing that we are quite keen on is looking to utilize the IPv6 data plane, so incorporate the Scion header into IPv6 extension headers. That's also work that's ongoing. And then also running, this actually isn't on the, oh, it is actually on the slide. We just added that. So running Scion over multipath quick as well. So this does have some information in it. We have started to document this. It's still much of a work in progress at the moment, but we are looking for further inputs into this. Then we have the deployment issues draft. So again, this came up from a suggestion, I think, from various reviewers that Scion has been deployed and is used in real networks. So at the moment, the two main deployment scenarios are sort of Scion-based network. We also have the Scion gateway. So this allows pre-existing, well, shall we say, legacy IP networks to be channeled across a Scion network. But potentially we can also enable Scion hosts as well. That's something that hasn't been a much deployment, but it will certainly is in the sort of future scenarios. We have done quite a lot of work around how you actually run and establish and run an isolation domain. So we have the experience of the secure Swiss financial network to fall back there. So, you know, I think this is really a sort of best practice implementation guide we're talking about here. Perhaps just going down the list, I mean, some of these are probably self-explanatory, how you establish and run a Scion network, how you add and remove networks from isolation domain. But one thing that perhaps there hasn't been really a lot of deployment is connecting between isolation domains. So there isn't a great deal of experience around that at the moment. So we're kind of interested to, well, actually try this and then document this. Sign IP gateway, which I've mentioned. So actually this came up when we were working on the data plane draft. It was sort of pointed out that this was mentioned and not documented. So we went out and there was quite a bit of documentation around already in different places, but we actually made quite a big effort to pull this together. Initially that went into the data plane draft, it just added too much text and it ended up almost being well, it is effectively another protocol. So what we'll do with this, this may end up being another draft. It may get documented in this draft. We haven't quite decided on how to go forward with that. And then a couple of other things. So PCB propagation policies, this has been added quite recently. And then the last one is, I think I mentioned, you know, how you would deploy Scion on end hosts and how they would choose, how they would undertake path selection across a Scion network. And I think that's probably it.
Any questions? Tim?
Hi, Kevin. I haven't seen you for ages. I just thought I'd say hello. That's not a question. It's good to see you. Yeah, thank you for that. I just looked at the draft, having not been aware of it, and saw it's basically a skeleton without any text in it. But I think once it's fleshed out, that's going to be really useful. We've had one UK university ask us about deploying and using and testing Scion. So it'll be useful to be able to point them at that sort of thing. I mean, essentially, it's documentation to extent, but it's also in the context of everything else you're doing. So I think that's what makes it more than just a README. So I think it's very useful. My question about the deployment model, or maybe it's, I'm not sure which of these texts it is, the isolation domain. I mean, isn't the point of an isolation domain that it's isolated, or is it then not an isolation domain once you start connecting them together? A little confused with the terminology. Yeah. I can imagine, for example, if you're doing Scion for banking and so on, they probably want to be quite isolated, but the RNE networks, probably people want to work together more.
Yeah, I'll take this one. I think here there is a naming problem, but this has been called this way for a while. Okay. So in terms of connectivity, so isolation is in terms of trust. So each isolation domain has its own root of trust. And if you want to enable communication between the two of them, then basically the root certificates, or what we call TRC in Scion, they have to be mutually trusted. Okay. So there can be communication. But yeah, in the questions that we have is, for example, how do you establish this trust? Is it trust on first use, or do you do it manually, or so on? And this really depends on the use case. As you mentioned, the finance network, they're a bit more reluctant. I think in the education network, and there will be a talk about it later, then I think this is a lot more connected.
Okay, thank you. And the second question is, as an NREN, we're always wanting to support what our researchers want to do within reason. So at the moment, it's one university that's interested. If 2 or 3 become interested, then having an idea in here from the sort of our point of view, we're not just the end user in terms of how we might support them, rather than them connecting through to Switzerland or whatever through a VPN from Janet, understanding how we might have some infrastructure that they can connect to, that sort of side of it as well, if that's possible. Is that something you would add to this? I didn't see it in there.
I didn't understand. So
Let me try and rephrase the question.
Can I try and rephrase the question?
Uh-huh.
So you understood it? Okay.
Yeah. So yeah, I understood it. Yeah. So basically, guidance for an organization that is providing connectivity to multiple sort of customers, in this case, members. Members is more the model for universities for an NREN. Like guidance for them in establishing like one versus multiple ISD is like sort of like taking the concept and making it practical, I think is what you're asking
Yeah, so
for,
I think
right?
while it's one, then we'd have them speak to you. But if it's
Right.
six, it makes sense for us to do something.
Exactly.
we might then
Yeah.
connect that. So that kind of how we'd go about that and what we need to do would be great.
I think that is a great question for the deployment draft. And then I think the education network, they also have their own docs page. So maybe we can feed this back to them
Yes,
so
I
that
think
they can.
Kevin's very familiar with those.
Oh, yes.
All right, thank you.
Hi, Luigi. Just two curiosities in a certain way. On slide 10, I guess, you mentioned QoS. Since this system is mostly used for banking, at least for now, what is the kind of QoS, quality of service, you think of? Is bullet 2?
Yes. To be honest, this is something that was researched by the ETH guys, so I'm not fully familiar, but the idea is to have some kind of inter-domain bandwidth reservation, which is something I think very hard. And I think they have had several proposals over time, but in practice, when you look at the actual deployment, this is not deployed. So this is more a research, idea.
Mm-hmm. Thank you. And the second curiosity was, I think, slide 9. You mentioned future evolution of the protocol. If there a version number or something that allows me to distinguish between two versions of Cyan, if you go in the future?
I think it depends. There are some fields that have a version number, but when you look at the data plane, there is no version number there. I mean, if you have a data plane, then this would be at some point a breaking chain. So, for example, one of the idea that was floated around was this using IPv6 extension headers instead of our own thing, and in that case, that would be a breaking chain. It could be something that you might roll out per link, maybe, because Cyan in the end is there is an intra-ES part, and there is a router-to-router link. So might be something that there could be some translation, but this is not. We haven't really thought about it, but that's a good question.
Thank you.
Thanks.
Okay.
All right. Thank you very much. And then next up we have Tony. Is he? Yes.
Yes. Okay. No, wait.
You need to
Yeah, I need to.
actually just remove him from the queue. Now he's up, and then you can hand him.
Yeah.
And we need to stop the slide share and then hand him slide control, because otherwise he's just showing these slides.
Stop slides.
Hi, Tony. We can see you. Can you hear us?
Yeah, I can hear you.
Excellent.
Can you hear me?
Okay. So, do you run your own slides, or you want me to show? Okay.
Boom. Yes.
You run through all the slides.
Right. Shall I start?
Yes,
Please
please.
do.
Okay. Hello, everyone. I'm Tony John. I'm a research associate at the University of Magdeburg in Germany, and my talk is about the Cyan Global Research and Education Network. So I hope you are all familiar with the Cyan Internet Architecture, so I'm not going through its benefits again. Looking at the deployment challenges we faced while deploying this research network, as with the deployment of any disruptive technology, the deployment of Cyan 2 had its challenges. The RFC 9049 outlines some of the obstacles in deploying path-aware networking, and the Cyan Association has also picked it up and presented the Cyan overview draft, which mentions some of the pitfalls, possible pitfalls. So our take on what makes the Cyan deployment complicated is the circular dependencies among key factors. The slide shows some of these dependency loops. Institutions may hesitate to deploy SCIAN without widespread adoption, while broad adoption relies on broader support from applications. We see this issue reflected across various dependencies, from hardware and OS support to ISPs and application adoption. So today, SCIAN operates on two global deployments. One is SCIAN Lab, which is an overlay testbed running as an overlay on today's internet. It allows users to establish autonomous systems within minutes. In this, we have over 35 permanently deployed ASs around the world and a large number of user ASs as well. On the other hand, we have the SCIAN production network. This is not an overlay. It runs natively independent from BGP and therefore also fault independent from BGP. It is deployed in various international ISPs, and it is the first global public secure communication network. There was a presentation related to this by Fritz Steinmann from SIX in one of the previous PANRG meetings. So the question is how to overcome these circular dependencies. And one of the ways we think is through a virtuous cycle to break the dependencies. So increasing number of applications with native SCIAN support increases SCIAN traffic. This incentivizes ISPs to increase SCIAN deployment. This in turn reaches more users, leading to more applications adopting SCIAN, and the cycle continues. This we hope will help SCIAN reach the escape velocity. And once it has reached the escape velocity, SCIAN will be a third way to communicate in the global internet in addition to IPv6 and IPv4. So how do we prime this virtuous cycle? To this end, we have undertaken the initiative to provide universities and research institutes access to this SCIAN production network. So this deployment has already reached quite far. At this point, we have around 250,000 users that have access to native SCIAN. This includes institutions like entrance, universities, and research institutes, as you can see listed in the slide. We believe that if applications with only 4% user base at these institutions, then we would already have around 10,000 users. And we believe that this can be a critical mass to be interesting to app developers to support SCIAN or adopt SCIAN into their applications. And once these applications are deployed, the traffic increases, setting this virtuous cycle into motion. Here we have a snapshot of the current deployment of SCIAN, of the SCIAN Research and Education Network. As we can see here, there are 4 major networks providing connectivity: Giant in Europe, Creonet in Asia, and Internet2 and Bridges in the US. In the case of Internet2, they only provide the connectivity, whereas Bridges is offering the server infrastructure to run these SCIAN ASs, these actual SCIAN ASs. And in Switzerland, Switch connects the education isolation domain to the rest of the SCIAN production network. It is important to note that all of these links are layer 2 links, independent of BGP. In Europe, members of GIAN can access SCIAN through the GIAN Plus circuit. They have points of presence in Geneva, Frankfurt, and Paris. When it comes to Creonet, they have 6 servers deployed all over the world, including Amsterdam, Chicago, Seoul, Seattle, Hong Kong, and Singapore. The interesting characteristic here is that CreoNet is really providing worldwide connectivity, namely in both directions around the globe, from Europe to Asia, Asia to US, and also from Europe to US. In the case of Internet 2, we have the Internet 2 AL2S that offers connectivity to the Internet 2 partners, and it enables us to establish various multi-point VLANs to connect these institutes, like the KIST server in US, UVA, Fabric, Princeton, and Bridges runs the core autonomous systems. They have presence in New York City and Washington. The Brazilian research network RNP is also connected to Internet 2. In Switzerland, Switch has established SIGN connectivity across all major Swiss universities. It represents one of the most extensive national research and education network deployment in the SIGN educational isolation domain. Looking at the characteristics of the SIGN deployment, our deployment is very heterogeneous. That is, we are running the commercial SIGN stack from Anapaya systems, and also we are running open source SIGN stack, and these are interoperable. We are also observing a mixture of operational models. There are ASs that are managed by us or by Anapaya, and also there are ASs that are completely self-operated and managed by the universities or the institutes themselves. Due to this heterogeneous deployment and operational models, we have encountered almost every corner cases possible. In the SIGN research network, we have over 25 ASs, including entrance universities and research institutes, and we are present in all continents except Australia. So coming to some of the evaluation results of the deployment, on the top left, we can see the number of paths between different AS pairs. We can see that in some of the AS pairs, we have almost 100 paths between them. And we can see a distribution of number of paths between AS pairs. So this makes the deployment having a high path diversity. On the top right, we can see the path stretch among different AS pairs. So we can see that for 80% of AS pairs, the best path and the second best path have very similar properties. So we can say that we always have a really good alternative path. At the bottom left, we can see disjointness of paths among AS pairs. Here too, we can see for almost major portion of the AS pairs, we have a high degree of disjointness. This helps in being highly fault tolerant. On the bottom right, we are looking at the connectivity between AS pairs if links are failing, and we can see sorry, you can see that even if 20% of the links fail, 80% of AS pairs are still connected when they are operating in multipath mode. Moving on, so to simplify the usage of SIGN, we have a bootstrapper infrastructure that makes it really easy to configure SIGN for foreign hosts and local applications. And we also provide libraries in Java, Golang, and Rust so that developers can include SIGN connectivity into their apps. We also have an awesome SIGN page where we list some of really cool SIGN projects. Here are some of the tools that you can use. We have debugging tools like ScienPing and ScienShow paths that shows the paths between an AS pair. We have a browser extension for Chromium-based browsers that can be used to add sign connectivity in browser. We have a packet inspector that you can send packets to and see those packets on a web page. Right. To take this further, we want to tackle some of the open questions, specifically how we can integrate sign into endpoints. We have examples like SVCB, Happy Eyeballs, and NPQuick. And as an example, we have proposed integrating deadline-aware streams into multipath quick using DMTP, which uses mechanisms that involves SCIAN multipath. It leverages SCIAN's multipath capabilities. And we have created a thread on the quick mailing list to discuss this and to get feedback. And feedback from PANRG would also be really appreciated. So to conclude, you can see that SCIAN is expanding, and with the SCIAN Education and Research Network, we have already 250,000 users with native SCIAN connectivity, and we hope that this will be a critical mass for native SCIAN applications to emerge. We would also like to tackle the open questions on how to better integrate SCIAN with the endpoints. And if you'd like to know more about the SCIAN Research Network, you can follow these 2 links. Thank you very much for your attention, and I would be happy to answer your questions. I would also want to add that Nico and Kevin is on site if you have questions afterwards.
Cool. Thank you very much, Tony. Any questions? Queue is open. Tim, come on up.
Hi, Tim Jones. So it's sort of linked to the question I had before, that if more UK universities say we're interested in using SCIAN, how does this model that's currently there scale up? At the moment, it seems to be a lot of sort of manually configured layer 2 tunnels, quite a lot of them, which is good, I suppose. But obviously, if you keep doing that, that's going to get quite messy, shall we say. What's the sort of 5-year view here of what's going to happen with this? In terms of, you've talked about the gateways with IP, but where's this going? And as an operator, what might I expect to do or see on my network with respect to SCIAN support? Does that question make sense?
So the goal with the Research and Education Network is to get SCIAN connectivity into all of the universities and entrants. So the end goal is not to use an IP gateway like the SCIAN IP gateway, but to have applications that have native SCIAN connectivity.
But that would mean you would need a layer. You might have on the NREN backbone some POPs that are SCIAN capable, and then layer 2 tunnels from those into the campuses. Is that where this is going?
Mm-hmm.
Okay.
So
that's a lot of
yeah. So the research network is currently under one isolation domain, and it is connected to the SCIAN production network, and that is run by different ISPs.
Okay. So that is that's where it would head long term. It's not like where with V6 we had all the loop of tunnels everywhere, and then eventually it went and we had dual stack. There's no kind of dual stack SCIAN IP or whatever. This is actually going to be tunneled forever, or where is it going? Am I asking a silly question?
I would pass this question along to someone who's more capable to answer that. I don't have the long-term, I don't have the bigger picture in this case.
Okay.
Nicola,
Right,
would you
sorry,
like
I
to come up
shouldn't-
and answer the group of tunnels question? I'm stealing that, by the way, Tim. Group of
Okay,
tunnels
yes,
in
you're
general.
welcome.
I mean, I would point out that like it's a network that was sort of founded in Switzerland, and Switzerland really loves tunnels. So there might be some of that, just like straight tradition. But I think Nicola will have a more serious answer.
In that sense, I think in Switzerland, where this has matured more in the finance industry, for example, at SwissIX, they have a layer 2. Basically, they have a separate VLAN for the peering fabric. So there they use a separate layer 2. I think it might go in that direction if it matures. I think right now I'm really not familiar with the deployment of the education network. But I think if this matures, then we should move away from tunnels. But yeah, probably for now that's the quick way in this network. But once again, we are not directly involved there. So yeah, that's a good point.
So coming back to my first question, so I think as an NREN, we would expect as one or two universities who are interested, they'd all get a layer 2, the Jout, as we saw it on the slide somewhere, the Jout layer 2 service to switch. But as more come online, we would presumably provide some connectivity to them. But then beyond that, we need to know where it's going and whether we're going to have to be expected to provide those tunnels forever. So something in that document that was 2 presentations ago that maybe paints that picture of where this is going if everything goes well. And so far it has, then that would be really useful. Thanks.
Thank you. Anyone else? Going once, going twice. Keith, come on down. Thanks a lot, Tony.
Okay. So,
You want to do the, like ask to present slide, so
Yeah.
stop the slide
Yes.
thing and then you can do it.
How do you want to do it?
You can do it with the
or
phone.
you can talk to me, I can show a slide and you just say next one.
Let's do it with the phone.
Yeah.
Okay.
That actually works quite well, so
Yeah.
we might as
Can I
well
use
use
this
it.
thing?
That we'd have
No.
to plug into the thing. Do you want to plug that into your? It's just a. You
No.
can do that too. No, you can't.
wait,
No,
hold
wait.
on.
Do you have? No, that's
No, I
that's
don't.
a.
Yeah, I don't. No,
If
I
you
can
plug it into the
this
HDMI
inside.
connector, it's not going to work very well. Yeah, so let's do the thing.
I'll try this. I'm on this square. Is it going to be buttons for me?
So-
Ask slides.
Ask slide. And then let me.
Grant slides, and then you select your slide. Slides from the list, and then they will do the thing. And 1, 2, 3. There you go.
Okay, wonderful. Thank you for having me. I am not Gina Yuan. She could not make it today, so I, as her advisor, am here to present in her stead. We're giving an update on our work with Michael Welsel and others about Sidekick, which is a scheme for in-network assistance like a performance-enhancing proxy, some sort of proxy of an arbitrary encrypted end-to-end transport protocol, like QUIC or like anything like that. So the setting here, at least one setting, is, imagine you're on a train, you're on the left, and you're sending data to some data receiver over some flaky Wi-Fi connection, Wi-Fi hop, to some sort of access point, and from there on to maybe a larger latency, reliable, wide area path. You might observe, for some reason, a TCP connection has very high throughput, but a WebRTC connection doesn't work very well, and even QUIC doesn't work very well. That seems kind of weird, but you can measure this. This is a measurement in emulation. We have some less stark measurements in real life. But as the loss percentage on that first subpath, first path segment on the wireless link goes up, this is with qubit congestion control, the QUIC throughput goes way down, and yet the TCP throughput does not. Can anyone guess? Why would this be? Why would TCP provide better throughput in this concatenation of path segments than QUIC? Why would this happen? Are you allowed to ask questions?
Yeah, you're totally
Okay, yes. Why would this happen? Seems crazy.
You probably should have had an audience plant.
Audience plan? Okay. Well, one reason it can happen is because there may be, and in fact, it's very often, there will be some sort of performance enhancing proxy for TCP on the path. The access point will be splitting the TCP connection and speaking TCP from the laptop to the access point, and then a different TCP connection from the access point back to the data receiver. And so loss that occurs on the lossy path can be recovered from very quickly. Whereas with QUIC, and this is very common, between 20 to 40% of internet paths are said to have some sort of TCP accelerator on them. And these are all evil, I think we'd all agree, and yet they do help. I don't know, do we agree?
I think saying that anything other than PEPs are bad in this room, well, no, this room is probably good. The rest of the IETF, you might
Okay,
want to
many
deal with,
people
yeah.
think PEPs are bad. And yet they do, in some cases, especially the unusual cases, help performance. Maybe the typical networks they don't, but the sort of long tail they really do. And with QUIC, as we all know, you can't do these things because QUIC is encrypted end-to-end. There's no way to have a transparent proxy in the middle. So these performance enhancing proxies have a dark side, right? They ossify the existing protocols. The middle boxes start to enforce their preconceptions about what the end-to-end protocol will do, and this makes it hard to evolve the end-to-end protocol. Many schemes to improve TCP have died at the hands of middle boxes. ECN++, TCP, can I say that died? No one uses it. Yeah, okay. So these things have not been deployed because in practice, TCP is ossified because there's 20 to 40% of these paths where the middle boxes enforce their preconceptions of what TCP can do. And research schemes like blind box or these kinds of things, you know, these also would require a complicated co-design between the end-to-end protocol, whether that's going to be some version of QUIC or something like that, and some current version of the middle boxes, and those middle boxes will never be upgraded, and so you'd end up being stuck with your end-to-end protocol. This is not going to work either. So what we've ended up with instead is a world where transparent middle boxes are just impossible. The newer generation of transport protocol, I can call these transport protocols, right? Okay, great. Newer version of transport protocols like QUIC, et cetera, encrypt and integrity protect end-to-end the connection. So it's just not possible to have any sort of transparent assistance in the network. So the question of this work is, can we decouple these things? I think Michael told you about that in Vienna at IETF 113, and now we're here to say yes, there's at least in the research sense, a way to decouple these things, to have a sidekick protocol, a totally independent, adjacent protocol that helps an arbitrary, unmodified base connection of a different transfer protocol. And you don't have to change that base protocol. It could be QUIC, could be something else, but the point is it is unmodified on the wire. So the idea here is that the data sender remains king, or the endpoints remain king. There's an encrypted connection end to end, but there is some sort of proxy in the middle that has its own connection with at least one of the endpoints, maybe typically just one of the endpoints, to help it out. But that is a separate connection about the underlying connection. Is it clear what we're trying to say? So we're trying to avoid the ossification that you get with these proxies by decoupling these things. So if you think about it from a deployment point of view, we really want that base protocol to be unconstrained. We don't want to ossify the base protocol. That's kind of the whole point. We're not trying to say, oh, QUIC needs to do X, Y, and Z. We don't want to change QUIC at all. The proxy is going to be something on the path, something that can see traffic on the same UDP4 tuple. The proxy is not necessarily part of the local networks or of the sender or the receiver. So we'd have to talk how you discover this proxy. It's not going to be like, oh, DHCP is going to tell the sender or the receiver about it. This is something on the path somewhere. Think about like a satellite network or a cellular network. Performance enhancing proxies are very common on these kinds of networks, but they're not something that the endpoints would learn about from DHCP or some sort of local configuration mechanism, and the server wouldn't either. And the proxy needs the ability to send directly to an endpoint. We're not talking about modifying something in flight that would go to the end-to-end receiver and then be reflected back. That's going to be way too late to help. The proxy needs to be able to send directly to one of the endpoints, and it needs to be able to get through a NAT, which probably means sending on the same UDP4 tuple as the underlying connection at least once. All right, so there's some complicated deployment.
Don't say spoofing. Sending on the same 4 tuple, right?
Once.
Okay.
Well, but so that could happen. That could happen on path. That could happen in the forward direction.
Yep.
And the idea would be that there would be some sort of introduction mechanism where the proxy would say, hey, I'm here if you want me. That could be reflected off the receiver. And here's a nonce, and here's where to find me. And then if an endpoint is interested, it can make its own totally independent connection to that IP address and port number, and that would not need to be the same for tuple, but there need to be some introduction mechanism. And what's also important here is that typically we'd imagine that at least one of the endpoints is unmodified. So maybe the server is speaking this sidekick connection with the proxy, and the two of them are talking sidekick, but the receiver is totally unaware and totally unmodified. So it's not something like where the proxy and sender and receiver are all ganging up. Okay, so that's the deployment. All right, so if we had all this, how can an in-network intermediary help the sender or the receiver without being able to perceive the plain text of the datagrams? With something like TCP, it's very easy to produce, an acknowledgement, a cumulative acknowledgement, and a selective acknowledgement because you see the sequence numbers, and the sequence numbers are in plain text. But if you're looking at a bunch of encrypted packets, whether that's QUIC or MOSH or something else, it's much harder to come up with a concise summary that would be of aid to one of the endpoints. How does the in-network intermediary express his point of view? You can't just have a cumulative acknowledgement because you don't know what's missing. See, in this picture, it's very easy to see number 13 is missing. So that's, what should be cumulatively acknowledged. But in this picture, you have no idea what's missing. So it just doesn't seem like it should be possible. And this is where Michael and I's conversation was as of 2021. We didn't know how to solve this problem. It's like a math problem. But I talked to my colleague who's a coding theorist, and she thought it was very easy. She sent me an email with all this math, and I didn't understand it. And then she thought it was so easy, she made it a homework problem in her class. And Gina, the student, was in that class and solved it. And then the professor was like, oh, you should really talk to Keith. He was interested in this. So that's how we ended up working on this. So Gina came up with this mathematical scheme called a quack, which is a way to express, I'll just skip, there's a lot of math here, a way to express how to talk about the encrypted packets of an underlying connection, even when those just appear like randomly jumbled data. So you can imagine some stupid ways to do it. The middle box could just echo every, let's say a secure hash of every packet contents that it sees. So you see these encrypted packets flying around, maybe you pick some bytes at random from the middle of them. It's going to be basically random anyway, it's encrypted. And you could just concatenate those and just send them back. Say, these are the packets I've seen. That's a really big message. That you're losing all the benefits of a cumulative acknowledgement. You could just try and hash these things, but now it's very expensive. And anyway, long story short, with some fancy linear algebra that she couldn't make it here because she's too smart. But anyway, with some fancy linear algebra, you can do this in nanoseconds, it turns out. You can produce these identifiers. I'll just skip past here, but anyway. With some fancy math, you can actually produce a concise digest of the packets that the intermediary has seen and can acknowledge without them having to follow any sort of structure. So they can be encrypted, they can be arbitrary, they can be unconstrained packets of the base connection. And still in nanoseconds, the sender can then perceive, oh, this is the missing packet. These are the packets that did not make it to some intermediary point on the network. Okay, so now the question is, with that information, what should the sender or receiver do with it? In the case of a split TCP connection that's being accelerated transparently, it's not really a decision for the sender to make. It just happens transparently. But here we're saying the middle box is just going to provide information to the sender, and the sender will decide what to do. It could be very valuable for the sender to learn that a packet was lost, because it can trigger an early retransmission. It also could be very valuable for the sender to learn where a packet was lost, because it can trigger a different congestion control response by knowing where along a path packet loss is occurring. So the idea here is to come up with an appropriate congestion control scheme that is informed by knowledge of where along a path aware, hey, where along a path loss has occurred. And the idea here is to emulate the performance that you would get with a split connection. So if you look at the same graph from before, you can see the end-to-end QUIC and the end-to-end TCP both do quite poorly when we have this lossy path segment at the beginning. And this split TCP connection does very well. Now this is fair. This obeys the host requirements document. But the middle box here, the splitting middle box, is doing a lot of assistance by allowing the sender to perceive very quickly when a packet was lost on that near path segment and retransmit it. So you could imagine, what should the sender do in the case where you have an end-to-end encrypted connection, like a QUIC connection, but the sender is learning very quickly about packet loss that has occurred on the near path segment. So you could say, well, just do the same thing as you would do in the end-to-end connection, but then you don't get a performance advantage. You could say ignore the loss if it happened on the near path segment. That's not very good either. But what we can also do is try to emulate those two individual congestion windows and produce something pretty similar, in this case, definitely less aggressive than the split TCP connection, just by emulating what would have happened if it had been a split TCP connection situation. And we have some math for that too. I'll just skip that. So she implemented all this. We used the Cloudflare quiche library, quick implementation, which is different from the Google quiche library. And you can do all these computations in nanoseconds. And here are some measurements in emulation where you can see the performance benefit of doing this kind of thing. So in the middle, I guess there's no way to gesture here, but in the middle graph, you can see sort of a throughput benefit for an upload over HTTP3 of various sizes. And here the sidekick assistance is very valuable to something like Quick. Here's a real world experiment over an actual Wi-Fi network where there's still a performance benefit, but not as good as was seen in the emulated experiment. But still, there's definitely a significant benefit in some of these edge case networks, like a satellite network or a flaky Wi-Fi or these kinds of things, the kinds of networks that providers don't necessarily provision for as well, by being able to emulate the performance of a split connection. So again, I want to go back to these deployment considerations. I think there is a lot of benefit that endpoints of an end-to-end encrypted transport layer connection can receive by learning from the perspective of some in-network intermediary, that intermediary's point of view on what's happening with the connection. Learning about loss as early as possible is helpful. You can imagine richer intermediaries that might retransmit packets, this kind of thing. We think we want to be in a world where the base protocol is unconstrained. We don't want to be saying, oh, let's change Quick, this kind of thing, or change WebRTC. Oh, that's wrong.
Don't worry. There's some middle box stuff happening inside MeetEcho. It's amazing.
So we want to be in a world where the base protocol is unmodified, and at least one of the endpoints that speaks that protocol can also be unmodified. So the idea would be that a sender, maybe that's a CDN, can be talking to some receiver, maybe that's a web browser, and maybe only the sender and the proxy are in on this sidekick connection, and the receiver could be totally unmodified, and the wire protocol is also totally unmodified. To do this, you need some way for that proxy to kind of announce itself. But from that point on, the proxy is probably just going to say, hey, if you're interested, contact me at this IP address and port number. Here's who I am. Here's some nonce or connection ID, so you know that I really was able to observe the on-path connection establishment or something like that, and then have a totally separate connection over a sidekick protocol that is about the base protocol, which remains unmodified on the wire. So that's the idea, and that's some sort of preliminary performance measurements to motivate it. And I think we are curious the level of interest from this community and the implementer community in these kinds of techniques. I would love to hear your feedback.
Peter, come on up. And then I'm putting myself in the queue as an individual, so I'm going to go down to the floor as well. just to mess with you.
Hi, it's Peter. I'm more like to discuss about the security part of this thing, other than the protocol side. So when I said about something about magical math or crypto, I kind of, very quickly I take a glimpse that it says Bloom filter.
Does
it use Bloom filter?
No.
Can you go to where there's a page that says the
math,
the name of the paper? There was a page that you mentioned.
Subset reconciliation, this kind of thing?
Before this, there's one before that. It says fancy Bloom filters.
Yeah, we're not using the Bloom filter.
Okay, all right. I have to look at that paper.
Oh, but was there a question, or you just don't like Bloom filters?
No, I think when I'm thinking of Bloom filters, I think about false positivity and all these kind of fine tuning you have to do with it. But if you say it's like a fancy Bloom filter,
well, I think we maybe should be clear about the threat model here. So some intermediary has proven that it is on the path, in the sense that it at least was able to modify some datagram and observe the connection establishment. So there's some intermediary that can at least observe the UDP4 tuple. And this intermediary is now telling you, basically, yes, I saw this packet, or no, I didn't see this packet. So I think the security implications from that are probably what you might expect. If the intermediary tells you, I didn't see this packet, if the sender uses that to trigger an early retransmission, then that intermediary could coax you into, a congestion control backoff, these kinds of things. On the other hand, an on-path intermediary can already do that kind of nasty stuff to you. They could actually drop the packet. So I think, obviously, as part of standardization, there need to be a much more searching security inquiry. But, I think the question here is, what is the threat model for what an on-path intermediary should be able to trick you into doing? And I think that would be a good discussion.
Hi, Brian Trammell. I'm down here because I'm halfway here as the chair of the other thing that I chair today, Scone. Are you aware of Scone?
I am, but not as much as my collaborators.
You should probably follow what we're doing here, because there's a whole lot of, I don't want to say overlap, but there's synergy between what we're doing and what they're doing. So exactly this, the threat model thing keeps coming up in this Scone working group is credible threats of network violence, right? The idea is I can tell you that I can do something to your packet, and then okay, now I'm going to prove it. And I think there's a lot of stuff in this space that's sort of parallel to that. Scone is chartered to do one very specific thing because we don't want to boil the entire ocean, just a part of it. But that conversation, I think that's a group of people that would be very interested in this conversation. I wanted to ask again a clarifying question about sort of the not a bloom filter. Let's not even say bloom filter. So I understand one of your sort of graveyard pictures there was of blind box, right?
Yes.
And blind box was super cool because it took essentially a completely heat death of the universe intractable problem in multi-party encryption and turned it into a plausibly tractable but still maybe not the production ready version of that, right? It was I forget, it was a 4 order of magnitude improvement, but you're still sending snort rules worth a few gigabytes of data. I think that this seems to continue in that vein of saying, hey, if we make the problem more and more specific, we can make the solutions more and more tractable. This polynomial sum thing is not generally applicable. It's applicable to this ACK problem or problems that are shaped like it, correct? Or is that a question for Gina?
I think there's two questions here.
Yeah.
I think I think one contribution I'm trying to make here, this framework, is saying what I don't like about blind box is that it requires a sensitive co-design between the protocol that's spoken end to end and the protocol that's spoken between one endpoint in the middle box. And we're really trying to decouple that.
Okay, that's the thing you're trying to solve.
The end-to-end protocol is going to be whatever the IETF standardizes, whether that's quick or whatever, and we will make no demands on that.
Okay.
And that we'll have a totally separate psychic protocol that will just be about the underlying protocol. I think that's a big part of this. And that's different from blind box.
Yes. Okay. Very cool. All right. Thank you.
You're welcome.
Hi, Luigi. Pretty interesting work here. I was wondering if you thought about the threat model, because in a certain way, if I open a connection, at some point, somebody will contact me suggesting to adapt for whatever reason, okay? How can I trust and be sure it's not a man-in-the-middle attack that either say me stop talking or actually increase the data rate so that I actually floating on the other side?
Well, I think this credible threat of network violence is probably the right thing to want there. From anyone who's trying to discover a proxy on the path that they're going to listen to, that's probably what you need to see.
Thanks.
You're welcome.
I'm going to use this mic just to confuse you. Lars Eggert from Mozilla. Ooh. Hi. So I actually had the same reaction as Brian about Scone. So Scone is basically about the path telling the end system that, hey, I'm going to really like to ship your video traffic at this rate, so wouldn't you adhere to that voluntarily? And one approach is to encode this cleverly in the quick header so that you don't need a whole new signaling protocol. But if you had other uses for, like, I don't want to say signaling protocol, something like this, right? Where you have some collateral benefit, right? Maybe you get the scone information that says, you know, but also, you know, I saw these packets from you, or I didn't see these packets from you. Maybe there's some thing that we could sort of explore where there is some benefits. That the problem with Scone is a little bit that the shaper is sort of close to the client who's receiving the video, and so there's not really that much delay benefit from getting it like from a little bit upstream to the sender, but maybe there's some other things. Get that same student to look at that problem. She seems really smart.
She's very smart. I think there's probably a few areas in which we should all talk. One, as you know, is about how do you discover these proxies? I think there's a lot of overlap there. And do you want to?
I want Michael to come up to the, now we're talking about discovering proxies. I want him to come up when you're done and give an ad.
Great. So I think proxy discovery is one area of commonality between all these things. And a second one would be this question about, do you want, I mean, I'm sure you've thought about this, but do you want to specify scone in a way that ossifies quick? Maybe that's a tangentious way to say it. Or do you want to specify it in a way that is independent of the base protocol? And I think it would be beautiful if you can find a way to specify it that does not place requirements on the evolution of the underlying protocol.
How much bandwidth do you have to get in arguments in the scone working group?
Like long term?
Well, we're trying to do things very quickly, like short term.
We'll talk about it as a group.
Let's talk. Yeah. Okay. Yeah. Because I think that these, you know, as chair, I think these perspectives should be in the room, and I'm trying to figure out how to structure that room over the next 3 months.
Well, I mean, I think just tell me now if I'm going to win, and then we can just cut it short.
So no, realistically, right? I don't think there's unfortunately a chance that this will significantly impact Scone, because Scone wants to move fast and has a very specific use case. But right, this problem of middle boxes and encrypted transports and the network maybe helping isn't going away, right?
Yep.
It's really nice. It just solves like one of the issues that we had in designing something in this space very nicely, and now something opens up, right, where you can explore, and maybe there's something there.
Yep.
Okay, so this is a heads up
Thanks.
that we're going to have a side meeting on path proxy discovery, where we can continue the fun conversation about how much of that is related to Scone or not.
When and where?
And how we can do this in a technical viable way. That's also a path of relatively little resistance. And it's in Wicklow Hall 2, I think, or 2B or whatever it's called.
Yeah.
Today at soon, 6:30, I think.
That seems right.
Yeah, 6:30 for 1 hour. So it's before Stuart Cheshire's other one. That's it. OPPD, on-path proxy discovery, yeah.
And yes, if you are interested in that, then we can continue that discussion over there, and some of that discussion might come back over here to PANRG, et cetera, et cetera. So,
yeah,
please attend. And thank you, Keith, very much for coming in and playing PowerPoint karaoke. And yeah, we will see you the next time you drop by. I think we're done.
Yeah, I think we're done.
Yeah.
See you in Bangkok.
See you in Bangkok. Thanks a lot, everyone. Have a great rest of your day and rest of your week.